It's recording now.
Okay, it's possible, right? Okay, thank you so much.
Yeah.
Okay, so starting right.
Let me check. Now here.
Okay.
I cannot change the role to presenter, but only to host, okay?
Okay. Okay. Thank you very much.
You're welcome.
Hello, guys. I believe we started taking our assessment. You can see just one or two persons who have done that so far. I think we just have to do this so that we all be running up at the same time. Okay. Today we'll be looking at today we'll be looking at advanced computer hardware. We actually looked at the computer hardware from chapter 1, where we talked about the personal PC. So today we'll be going further with a deep dive into the advanced aspect of the computer hardware. Let's look at what the objective is. We'll be looking at how the computer system is being boot. When you boot the computer system, the processes it has to undergo. Configure the BIOS, which is the basic input-output system, and the UEFI settings. We'll also look at how the post BIOS and CMOS and UEFI are being described. We'll configure the computer firmware. We'll look at electrical power. Explain the concept of electrical power. We'll look at the wattage and voltage. We also look at power fluctuations and devices that protect against damage caused by fluctuation. So these are some of the things we'll be discussing. In addition to computer functionality, we'll also look at the CPU architecture. We'll also look at RAID, common port cables and connectors. Some of these things we have discussed before. They will go in a little bit advanced and describe monitor characteristics. We'll also look at how the computer system ought to be upgraded and select components to upgrade to meet requirements. Select appropriate components to upgrade a computer. And then we'll also look at components for specialized computing, protecting the environment, playing safe disposal methods to protect the environment. Some of the after long usage and some of the systems are no longer in use, how you have to dispose them to be able to protect the environment. And then we'll also explain safe disposal methods. Okay, so looking at the first subtopic here, which is boot the computer. When you boot the computer system, it goes through a number of stages. And usually it is being described as the post. The post is the power on self-test. So when the computer is booted, the basic input-output system, which is the BIOS, performs a hard check on the main component of the computer. It has to do this check to see if every other component are in place and actually functioning well. And so these are instructions that are already preset from the manufacturer, and then tells the way a manner the system must follow each time it's being booted. Some level of instructions. So these are like instructions, hardware program, born into this device to be able to help check the process of execution. So once the post is completed, and that is when your operating system starts loading. So this check is called an code alert of the problem. And that is why when you boot the computer, for instance, if your RAM is not well fitted, you get a beep sound. That beep sound tells you that something is wrong with one of the hardware components. Oftentimes for a RAM, it's so common that it's repeated, in that manner. And when you open up the computer system, probably replace the RAM with a function, a RAM that is working, you discover that that error is being eliminated. If you're not able to do that, in some cases, it might not actually be that the RAM is faulty. It might also be probably there's dust on the motherboard, and therefore there's no signal, from the RAM or signal going through the system. So in such cases, it will also be, what we're saying here is that once there's that bridge of communication from either RAM or the CPU, you always get this beep code alert, telling you that something is wrong. And once you troubleshoot, you're able to resolve the problem by either replacing or probably clearing up the dust from that device. So BIOS manufacturers use different codes to indicate different hardware problems. So you have different codes for different hardware. Motherboard manufacturers may use different beep codes as well. All these are just some kind of alert to tell you that you have a problem with one of the associated devices. Okay, so always constitute the motherboard documentation to get the beep code for your computer, so you know which beep code actually is associated to any of the hardware components. Installation: to determine if post is working properly, remove all the RAM modules from the computer and power it on. That tells you if the post is working, and if there's no beep sound, automatically the post is not working. The computer should emit the beep code for a computer with no RAM installed, and this will not harm the computer. So what we're saying here is that if there's a fault, then if the beep sound is there, the beep code happens, then that tells you that it's actually the BIOS is working. But if it's not, then something is wrong, and which have to be resolved as well. Of course, like I said, it's an instruction that is already preset inside the ROM, and then it is hardware born into the ROM such that you are not the one who have written that instruction, but that actually comes from the manufacturer. So all motherboard needs a BIOS to operate. So BIOS is a ROM chip, okay, on the motherboard that contains a small program that controls the communication between the operating system and the hardware. I think there's a vital definition that ought to be underlined. So you can see here that it contains that program that controls the connection between your operating system and the hardware. Automatically, you could also refer to it as a middleware. Middleware in the sense that it actually creates that interaction between the software part and the hardware part of the system. So along with the post, the BIOS also identifies which drives are available, which drives are bootable, how the memory is configured, and when it can be used. Okay, so how the peripheral computer interface, express, and PCI expansion slot are configured. So it also gives us that whole identification of how the expansion slots are being configured, how SATA, that's the SATA port and USB port are configured. Remember the SATA port for connecting your hard drive, or connecting your disk drive, and all of that. With the SATA, of course, replace the PATA port, and the universal serial bus, which also the ports for you to plug in your USB devices, also gives us some kind of indication on how they are being configured. The motherboard powered management features. So you can see a whole number of roles that the host to the BIOS helps us to identify and gives us some guide. So these are like more or less like part of the role being played by the BIOS. Okay, and so the BIOS and the CMOS. The CMOS, which is a complementary metallic oxide semiconductor. You can see the CMOS here. This is actually a chip on its own, but it's being powered by the CMOS battery. Okay, and so the motherboard manufacturer saves the motherboard BIOS settings in a complementary metallic oxide semiconductor. So if you recall, I said the BIOS is like a ROM, is a ROM chip, but then the settings of the BIOS are actually housed in the semiconductor, in the CMOS memory chip. That tells you that when a computer boots, the BIOS software reads the configured settings stored where in the CMOS. So the settings of the BIOS are actually stored where in the CMOS memory chip. So you need to get that for connection to determine how to configure the hardware. So that is where the setup files is, where you can actually configure the system before it starts loading the operating system. You also could set the date. You know, you could also password the system also from the BIOS, such that it will be difficult for some level of maybe some abuse. And then you can also see that from the BIOS, you can order the boot settings such that the order of boot up. You can decide to boot from the hard drive, or you boot from the DVD drive, or you boot from a USB device, just like one of us asked the question last time, if you could actually boot the operating system from a different device apart from the main drive. Eventually, the main drive is faulty. Are there other ways that you can still have the operating system all load up? And I said, or even with a flash drive, you can have the operating system and still call it up from there. So what we're saying is that the settings can be altered at the BIOS, where you can change the order of boot. The BIOS settings are identified by CMOS using a battery. If the battery fails, important settings can be lost. For example, the date and time. So you see the system going back to maybe the year of the manufacture, maybe the year the system was being manufactured. If it's manufactured maybe in the year 1992, you see the system going back to 1992 and all of that. You now need to change that date all over again. And once you shut down the system and restart, it also affects the date and time. And of course, if you could see here that when the date and time is being affected, it also affects some of the signature of the antivirus as well. So most of the programs that has to do with date and time are affected. So you could see the importance of the things here. So installation, if the computer's time and date are incorrect, it could indicate that the CMOS battery is bad or is getting very low. In some cases, it tells you press F1 to continue. So these are some of the things we need to note in the course of system troubleshooting. So most computers today run Unified Extensible Firmware Interface, which is called the UEFI. And all new computers come with the UEFI, which provides additional features and addresses security issues with legacy BIOS. So the UEFI is more or less like an extension of the original BIOS to provide some additional security features with the old BIOS systems. So you could see the UEFI as more or less as a more secured way, as a more secured way to get your BIOS working properly. So the UEFI can run on both the 32 and 64-bit systems, support larger boot drives, and includes additional features such as a secure boot. Okay, so secure boot ensures your computer boots to your specified operating system. That is what secure boot is all about. So this helps prevent rootkit more or less like attack from taking over the system. Of course, when we talk about the rootkits, we're looking at the entry-level attackers on our system. So what we're saying with the UEFI, you're sure that that can be averted. So that is the role of the UEFI on the BIOS system. And so in the lab, it's to investigate the BIOS of the UEFI setting. And how do you do that? You enter the BIOS. So if your system is booting, you need to check. You have some different functions for all the systems. In most cases, when the system is being, when you boot the system, most of the systems, I think when you press F2, it takes you to the BIOS settings. That is where you make all the changes. You can also know the right command when you boot the system and it's trying to load during the post process. It will also show you which of the function, the keyboard function, actually will help you to get into the setup file, get into the BIOS, and there you can now make your changes. Okay, so that's what's expected for you to do during the lab, and you want the video to guide the student. The legacy BIOS supports some security features to protect the BIOS setting. However, UEFI adds additional security features. So, like we said, it's more or less an enhanced security features for the BIOS. Some common security features found in the BIOS UEFI system include, so these are some of the security features you can get alongside with the modern BIOS, which has the UEFI. Passwords allow for different levels of access to the BIOS settings, which has to be provided for you to be able to have access. Drive encryption. A hard drive can be encrypted to prevent data theft. Okay, this you can do in the settings. In a load jack, this is a security feature that allows the owner to locate, lock, and delete the device. Okay. And then trusted platform module is a chip designed to secure hardware by storing encryption keys, data certificates, password, and data. So you can see a whole number of common features that are found in the BIOS. So once you get to the BIOS setup, it's expected that you have access to all the security features. And then the secure boot, which is a UEFI security standard that ensures that the computer only boots an OS that is trusted by the motherboard manufacturer. So with that now, it could be selected such that you're sure you're not using you're using OS that can actually work against the system. So that tells you that there are a whole lot of security that we can take advantage of when we get into the BIOS settings, try with the modern computers. Okay. So here we'll be looking at BIOS UEFI configuration, update the firmware, updating the firmware of the ROM. So motherboard manufacturers, they publish updated BIOS version to provide enhancement to system stability, compatibility, and performance. So there will be need for time to time system firmware update. So early computer BIOS information was contained in ROM chips, like I said, and upgraded the BIOS information. The ROM chip had to be physically replaced because we said that the BIOS is actually the ROM chip itself. So it means that if you must do the upgrade, you had to physically replace the ROM itself. So modern BIOS chips are electronically erasable, programmable read-only memory, which is the EEPROM, which can be upgraded by the user without opening the computer case. So this is called flashing the BIOS. So this you will do by flashing the BIOS because it's actually electronically erasable. So you're not going to physically remove that from the system, but rather you can actually flash it electronically. To download a new BIOS, consult the manufacturer website and follow the recommended installation procedures. So if the manufacturer is Dell, HP, what we're saying is that if you want to upgrade the BIOS, you have to get to the website and check for a particular kind of system, and there you follow the procedure for upgrading the BIOS. Okay, And then in the lab, this is expected to identify the current BIOS version and then search for BIOS EFI update files. This you can do by getting to the setup to be able to identify the current BIOS, so you could also see the version of the BIOS you're using in that activity, and then you look at the updated files. And then in this lab, you will install Windows 10 to be able to do that, because it seems to be one of the latest operating systems. So you will have to do that to check for the system BIOS and see the version you're having. So you also install and remove the third-party software application supplied by your instructor. You install the package tracer with Windows application. And so here we're looking at installing the package tracer. That's a third-party software to the system, and of course it will be used later on in this program. That's actually for the BIOS, the ROM, and the CMOS battery. So you could see the correlation between your ROM, your BIOS, and the CMOS. So we said earlier in chapter 2 the importance of power, which we all are aware power is critical, is necessary. If you must, safety must be considered each time you must use a system. And so here we'll be looking at some of the terms that are actually related to power. And there are 4 basic units of electricity that a computer technician must know all the time, so that he doesn't run into problem. He needs to understand voltage. Some of us are coming from background that are not science, so they are coming from background that are completely off from engineering or science, as the case may be, so or physics. And so we need to understand some basic terms on the electricity. So the voltage actually measures volt. The measure of work required to move a charge is what we call voltage. So the work that's required that you can move a charge from point A to B is called voltage. So the measure of amperes, as a measure of amount of electrons moving through a cycle, is called current. And so when you measure the particular amount of electrons you have in a particular circuit, you're dealing with current. And the resistance, it does refer to the opposition of the flow of that current in that circuit. So if the current is flowing, there's some level of resistance. And so if you have a current and you have a resistance, and you know what the amount of current is, and then you're looking at the resistance, you know the resistance value, automatically that gives you the voltage. Okay, so but then I also said in the previous class that power is equals to current times voltage. So here we now say power measured in watt, the measure of the power of the work required to move electrons through a cycle multiplied by the electrons, that multiplied by the number of electrons going through the cycle per second, is actually what we refer to as power. Okay, so a basic equation known as Ohm's law expresses how voltage is equal to the current multiplied by the resistance. So Ohm's law states that current multiplied by resistance is actually voltage, which expresses the Ohm's law theorem. So in electrical system, power is equal to the voltage multiplied by the current. So if you always want to know your power, look at your power adapter, look at your desktop power adapter, whichever you have, multiply the voltage that's given to you with the current. That gives you the output of power. So power supply voltage settings on the back of some power supply is a small switch. You can see we also talked about this in the first class. This switch sets the input voltage to the power supply to either 110 volts or 15 or 220 volts or 230 volts. So you need to be so sure which actually it's the standard you're using in your country, such you don't want a dual voltage power supply. Okay. Hello, are we there? Hello, can we hear me? Okay.
Yes.
Yes. So a power supply with dual voltage power supply.
Your voice breaks.
So when you have this kind of power supply. Hello, can you hear me?
Yes, we lost you for a few seconds, but we can hear
you. Okay, thank you very much. So we are actually talking about power here. That power, okay. So we're talking about the power supply does not have that does not have this switch that will automatically detect and set the current voltage. So if you have the type that does not have the switch to regulate between 110 or 220 volts, what we're saying here is that it means that the system on its own can regulate it. If you're in the area where you have 110 volt, it will work for you. And then if you actually in an area where you use 220 volt, like in Nigeria we use 220 volt. I don't know what is being used in Ghana, but I want to believe that Ghana and Nigeria is using the same voltage rating. So you need to actually adjust the power such that you're sure it's not going to cause any problem. Okay, so I believe we actually understand this part very well. Any question on this power issue? Okay, so let's go on. So the correct voltage setting is determined by the country where the power supply is actually used. So Ohm's law, in this lab, you will answer questions based on electricity and Ohm's law, which are actually available. So it's expected that as you're attempting the chapters exam, you also open up the lab. We have the lab manual on the NETA card. You open each lab manual and answer the questions as well. Because it's also form part of the assessment. We also want to talk about power fluctuation types. When the voltage in the computer is not accurate or steady, computer component may not operate correctly. So here we need to understand that power is important, such that if the right amount of power is not going through the system, it will also affect the behavior of the system. So the following types of AC power fluctuation can cause data loss or hardware failure. Example, blackout. Complete loss of AC power is called blackout. Okay, so that's a terminology for when you have a complete loss. And then brownout is reduced voltage level of AC power that lasts for a period of time. So reduced voltage level, which is probably somehow voltage, as the case may be, that lasts for a very long time, is called brownout. And interference from generators and lightning actually introduce what we call noise. So you might say, oh, there's so much noise in this power transmission or the voltage transmission, the case may be. Now, what you're saying is that noise brings some level of impurity in that whole transmission. And so it might not actually make the power stable, but rather it to fluctuate. And spike, sudden increase in voltage that lasts for a short period and exceed 100% of the normal voltage is what's called spike. And then power surge, dramatic increase in voltage above the normal flow of electric current. So you can also have power surge could be over voltage, can also be under voltage, as the case may be. Some cases you may not have adequate power voltage. Okay, so to help shield against power fluctuation, what do? You need a surge protector. You need a UPS to protect against potential electrical power problems. You also need what we call standby power supply, which helps protect against potential electrical power problems by providing the backup battery that is on standby during normal operation. All this is to be able to help you handle power fluctuation. So you need a surge protector, you need a UPS, and you also need a standby power supply. All this is just a way to eliminate power fluctuation, which, like I said, is not good for the computer system. So we're looking at CPU architecture. The CPU architecture. Remember, we said the CPU is the central processing unit, which is actually the brain of the computer. So a program is a sequence of stored instructions, and the CPU executes these instructions by following a specific instruction set. So a program is, like, we already know what the program is, but what executes this program on the computer is a CPU. So there are two distinct types of instruction sets that CPU may use. And what are they? The CPU may use instruction sets which is defined as RISC, and RISC is the reduced instruction set computer. These architecture use a relatively small set of instructions. So RISC chips are designed to execute these instructions very, very rapidly. Okay, and then we have the complex instruction set. This actually uses a broad set of instructions, resulting in a few steps per operation. So we have different equipment that required different instructions to be carried out, of which the CPU will behave in this manner, either as RISC or CISC, depending on the component. Even your camera, you have it using the complex instruction set. In this case, like IP camera, where you have a broad set of instructions resulting in few steps of operation. You don't. Hello.
Maybe I stopped the recording.
Hello, can we hear you?
Yeah, we can hear you.
I think
We can hear you.
Oh, I'm hearing myself all the way.
I think maybe you have to make me the host again. Sorry for that.
I think the recording is available. It's recording already.
It's available. Thank you.
Yeah.
Simon, could you please mute? Thank you.
Okay, can I go on, please?
Yes, please.
Okay, thank you. So we said the CPU executes instructions by specific instruction set. So the order in which the CPU must work must be based on these types of instructions. So there's a type we call the RISC, and there's a type we call the CISC. And so it's either using the reduced instruction set computer, or is using the complex instruction set computer. And so if he's using the reduced instruction set computer, it will execute this instruction very rapidly and very fast. And so that means in environment where you want execution to be very fast, you're meant to use the CPU with this kind of instruction. That means these are the kind of instructions that will guide the CPU on how to execute, how to fetch, decode, and execute instructions. And if you want it in an environment where it has to be few steps per operation and gradually, then you configure that the CPU is being configured to work with the complex instruction set process. And that actually means that if you look at most of the devices we have, they have CPU in them, okay? But their mode of operations and execution is not the same. The CPU you have in an IP camera is different from the CPU you have in a computer system. But they are all central processing units, which are embedded in most of the electronic devices. So what we're saying here is that they are either RISC or CISC, and they must work rapidly to give you resulting output. Then they are RISC. And if they needed to work and execute slowly per step to give you an output, then it's CISC. So while the CPU is executing one step of the program, the remaining instructions in the data are stored thereby in a special high-speed memory called a cache. So inside the CPU is what will have a cache. So most of the modern-day CPU, there's a memory, and there's a memory inside the chip, and that is the reason why in this modern-day we have systems of Core i3 or Core 3, Core i5, Core i7, because they now have a cache memory inside them, And this cache memory means that if the CPU must fetch information, it does not fetch information from the external memory on the motherboard. Rather, it already have an internal memory, which is the cache. That's the reason why for i3, i5, 7, we have variation in the cache memory. For instance, a Core i7 will have a cache memory of about 4 MB to 8 MB as the case may be. And the same you have for i5. So the higher the cache memory inside the processor, the faster the processor, because the processor now have an internal memory. So you could now have what we call the L1, L2 cache memory. The reason is just for information to move in what we call pipelining structure, where from the external memory it is emptied in L2, and from L2 it is emptied in L1, and from L1 it gets and it is executed by the processor, and there you have the output. That actually makes the CPU to work at a very fast rate. Unlike the legacy CPU we used to have, that each time it must fetch information, it goes outside itself to an external memory, fetch the information, and get back to itself, and then decode and then execute that information. So what we're saying here is that with the modern computers or modern processors, you now have memory embedded inside the CPU, and this helps to speed up the processor. So internal enhancing CPU operation. Internal processor uses hyper threading to enhance the performance of some of their CPUs. Okay, so with hyper threading, multiple pieces of code are executed simultaneously in the CPU, so a single CPU performs as though there are two CPUs. So what we're saying is that the hyper threading technology helps the CPU to perform as though there are two CPUs, even when it is one. All is just to see that there's some kind of efficiency in the performance. AMD processor uses hypertransport to enhance CPU performance. So the hypertransport is a high-speed connection between the CPU and the NOT bridge chip. Remember what the NOT bridge is? Okay, so the power of a CPU is measured by the speed and the amount of data it can process. And that actually is measured in hertz. So you could have megahertz, kilohertz. So hertz is the unit of the processor. The amount of data that a CPU can process at one time depends on the size of the front side bus, as the FSB, the front side bus of that CPU. Remember, there's a bus wire, so we're looking at the size of that. And that tells you what it can actually fetch. And so, if you must be able to talk about the amount of data a CPU can process, you now ask what is the size of the front bus, side bus, because that actually tells you the number of pathways and all of that it has to fetch. So with that, you can be able to tell the amount of data it can fetch, and then process over seconds. Okay. So overclocking. So here we're looking at how to enhance CPU operation. So overclocking is a technique used to make a processor work at a faster speed than its original specification. So overclocking is not a recommended way to improve computer performance and can result in damage to the CPU, of course. The CPU already has its own clocking rate. So if you now overclock it, care not taken, you could actually lose the system. So the opposite of overclocking CPU throttling. So the opposite of overclocking CPU is actually what we call a CPU throttling. CPU throttling is a technique used when the processor runs at less than rated speed to conserve power or produce less heat. And so if it is running at a very slow speed, the essence of it is to conserve power and produce less heat, of course. The faster it works, the more heat it produces, and if it works less, then the heat effect is also reduced, and that actually helps it to conserve power. So it's either you're doing overclocking to increase the speed, or you're looking at the opposite side of the CPU, which is overclocking. Sorry, what we call CPU throttling. Throttling is now a technique where the CPU actually runs at a less speed, which is completely the reverse side of overclocking. Okay, so all these to somehow be able to regulate the CPU performance. Either you want it to be very high or you want it to slow down, depending on the purpose in which expected or the desired objective for doing this. So you might want it faster, or you might want it to work below the default setting. So either of these will work for you depending on the kind of output you're looking out for. But carrying out overclocking might end up damaging the CPU if care is not taken. So the CPU virtualization is a hardware feature supported by AMD and Intel CPU that enables a single processor to act as a multiple processor. So it's called CPU virtualization. You can actually virtualize the CPU. Sometimes some of these works well with VM software and all of the application. So you can actually split the performance of the CPU across multiple systems, as if you have different systems all connected. But then it's virtual. So with CPU virtualization, multiple operating systems can run in parallel on their own virtual machine, as if they're running on completely independent computers. Why? Because this will be shared across the multiple operating system. So these actually, like for instance, Oracle VMware, when you're trying to do some kind of virtual experiment to test different connections from different sources, it's clear that in the process of installation, you have to also share the speed of the processor between your system and the virtual computer. So what we're saying is that these will run in parallel on their own virtual machine, as if they were running on a completely independent computer. So you could have that, but it's actually virtually configured. Okay. So still on the CPU architectures and operation, we're looking at multi-core processors. Multi-core processor has two or more processors on the same integrated circuit. So integrating the processor on the same chip creates a very fast connection between them. So the multiple-core processor execute the instructions more quickly than single-core processor. Instruction can be displayed to all processors at the same time. So you could see here that the load in which the particular processor was used to process one amount of information, you see that it displays across the multiple-core processor. So RAM is shared between the processor because the cores reside on the chip, on the same chip. So whatever RAM you have, it is shared. So if you have a 16 gig RAM, it has to be shared across the multiple core processor. So multiple core processor conserve power and produce less heat. There are multiple single core processor, thus increasing performance and efficiency. Of course, you have two processors running one system, and they are meant to execute some tasks. It's clear that these will be shared across the two of them. And what we're saying is that if it will be shared across, definitely the amount of data or the amount of information that will be processed over time will be smaller compared to when you have a single processor. So we have it in single, dual, triple, quad core, hexacore, and all of that. Octa-core, which is 8. So these are the different cores of processors that can actually exist in our systems. So the multiple core processor, another feature found in the CPU is an integrated graphics processing unit, or the GPU. So the GPU is a chip that performs the rapid mathematical calculations required to render graphics. So this is another feature which is actually very needed. So oftentimes when you want to make system procurement, you also check the CPU, the GPU, because you want to be sure that this actually can help process high volume of graphics on the system. So a GPU can be integrated or dedicated. So integrated GPUs are often directly embedded on the CPU and is independent on the system RAM. So while the dedicated GPU is a separate chip with its own video memory dedicated exclusively for graphic processing, the benefit of integrated GPU is cost and less heat dissipation. Okay, so integrated GPUs are good at less complex tasks like watching videos, processing graphical documents, but are not best suited for intensive gaming applications. So when you have if you have intensive gaming applications, what we're saying here is that it's not really the best per se, but it also helps to enhance that. But for your graphics, here the GPU, you need to look at the configuration and the specification. That actually tells you whether you'll be doing more graphics or not. Okay. You have the one that is integrated with the CPU. You have the one that is standard. The CPU cooling mechanism still on the CPU architecture. That tells you how robust the CPU is. So all we've been talking for some time now is looking at the CPU architecture, its operations, and all of that. Because the CPU is the brain of the computer, so there's a need to actually emphasize much about the CPU when you're talking about hardware, because it's the CPU that coordinates the activity across the south and the north bridge. Okay, so the CPU cooling mechanism, the case fan. So you might ask, what are we talking about case fan here? The case fan helps increase the airflow. And remember that your CPU needs to have a control environment. It must operate in a controlled environment where the temperature is regulated and not necessarily too high to destroy it. So you need a case fan that helps you blow out heat. So some cases have multiple fans with cool air being brought in while other fan is blowing out of air. So you could see you have fans that help you to kind of create that channel for airflow in order to be able to blow hot heat out of your system. So the CPU heatsink. So a heatsink has a large surface area. As you can see, this is a heatsink. And what the heatsink does is that once you stick this heatsink on
Dr. Daniel, I think we lost you.
the fan is known as passive cooling. So when you have a CPU heatsink, there's no fan connected to it, then it's actually a passive cooling. Not all the systems that have fan on the CPU heatsink. So the CPU fan, it's common to install a fan on top or within the heatsink in order to move it away from the mental things. So a CPU heatsink with a fan is known as active cooling. Remember, when it is not having a fan, it is passive. And when there's a fan on it, it is called active. So the graphics card cooling system. So the video adapter cards have a large graphic processing unit that generates excessive heat. Okay. So water cooling systems, a metal plate is placed over the processor, and water is pumped over the top to collect the heat the processor generates. So this is another way of creating some cooling effect, as you can see in the diagram to your right. Okay, so the water is pumped to a radiator to dispense the heat into the air, and then the water is what recirculated. All this is a way of trying to help to improve performance of CPU. So now we're done with CPU. We're looking at RAID concept. Looking at RAID concept, you might ask, what is a RAID? A RAID is redundant array of independent disk technology. So RAID provides a way to store data across multiple storage devices for availability, reliability, capacity, and redundancy, and performance performance improvement. The RAID is actually a technology where you have a particular system, you have arrays of hard drives, and these hard drives can actually do what we call stripping, mirroring, parity. All this is a way of trying to secure our data and make data available, reliable, and make the system, the storage to have more capacity, redundancy, performance improvement. Now, all these are features of the RAID. On the ground that the RAID has arrays of hard drives, and these hard drives actually work synchronously. In case one fails, the other takes over. And so we have a lot of terms to describe the RAID technology, which is stripping, mirroring, parity, and double parity. So stripping enables data to be distributed across multiple drives with a significant performance increase. However, the failure of a single drive means that all data is lost. Okay, so you could see here that when the RAID performs stripping, this is distributed across multiple drives with significant performance increase. However, the failure of a single drive means that everybody fails because it's distributed across those drives. So you can see that if one fails, others have failed. And a mirror installs duplicate. When it comes to mirror, you have a duplicate of that data in one or more drives, and actually provide that redundancy such that if one drive fails, it does not cause the loss of data because that information is actually mirrored in the other drive. And parity means it provides basic error checking, and fault tolerance by storing checksums separately from data enables the construction of lost data without sacrificing speed and capacity. So what the parity actually does is that basic error check, and fault tolerance each time there's transmission of data. And then double parity provides fault tolerance for up to 2 failed drives. So you could see here is the priority actually is to provide basic error checking, but this can help you also to provide fault tolerance up to 2 failed drives, such that if you have arrays of drives and one fails, always saying that in as much as you check this error for you, when it's double priority concept that probably runs on that RAID system, it will also check on to tolerate up to 2 failed drives, and everything will still be working. So you can see that the priority is to check error and also help you to create something called fault tolerance. Fault tolerance that even when 1 or 2 fails, it's still working for you. Okay, this technology actually can be found in most of our robust servers. They all have RAID. If you open up the servers, you can see different partitions for different drives. That helps you to be able to maintain your data. So even when one drive fails, another fails, you're still sure that you still have the mirror image of your data from the original drive being sent to the other drives in that whole RAID system. So there are several levels of RAID available. These levels all use mirroring, stripping, and parity in different ways. So higher levels of RAID, such as RAID 5 or 6, using stripping and parity in combination to provide speed and to create large volumes. So if you see here, we have RAID level, and if you could recall, we have the metrics that determine a RAID, which is stripping, mirroring, parity, and double parity. So here, we now have RAID level from 0, 1, 5, 6, 10. And if we have this level of RAID, we are also saying that there are features, okay? And these features I want to mention as a metrics. And what are the advantages so if the server has is of level 0, we're saying that it can do stripping, and it has a minimum of 2 drives, and it can take more than that. And performance and capacity, that's an advantages. The advantage is that all data is lost if one drive fails. Remember, we say stripping. All data is what? Lost when one drive fails. But we say in mirroring, that capacity is half of total drive loss. I mean, even when one fails, you still have it in the other. So you could see what RAID level 1 is 5, 6, 7. Sorry, 5, 6, and 10. It means that if you're buying a computer server, you could also check out the manual to see which RAID kind of system or technology you are actually getting. Reason being that so you know the features, you know the advantages, and when there's some kind of when there's a set in, you can actually know exactly what the problem is. So there's a need for us to understand or go through also as well to have more information on the RAID, how the RAID technology actually works. And so we'll be looking here on talking about legacy ports. Okay, so for serial ports used for connecting various peripherals such as printers, scanners, modems, and console connections to network devices. As in serial ports, they have the parallel used for connecting various peripheral devices also, like printers. So it's either serial or parallel. So we have the two. Okay, and then the PS2 to connect keyboard and mouse, and then we have the audio ports. These are legacy ports. They are way back then, but then most systems didn't have all of this, so this could be still backward compatible and forward compatible at the same time. So video and graphic ports, we have the VGA, we have the DVI, HDMI, display port. These are more or less features of the computer system that helps you transmit videos in more clearer and quality format. Okay. Then the USB cables are connectors. So you can see the USB cables and connectors. We talked about this in previous class. So we have the USB of 2.0, 3.0, USB of 3.2. Of course, this is the evolution of the USB speed and their standard. So if your port is a USB 2.0 or 3.0, it also determines the speed as well. The higher the USB port, the faster the speed. So USB type A, the typical rectangular connector found on almost all desktop and laptop computers, so TV, game consoles, and media players. So you can see the type A, and then you can see the mini USB, and then you can see the micro USB. So these are different types of USB device components of case, so USB cables and connectors. Okay. So still on USB cables and connectors. We've also talked about SATA cables and connectors. I explained this earlier also, so we need to open our systems to look at them. And then we have connectors and cables. So here we would like to look at the different connectors and cables that are actually needed in our lab or in our setup, network computer setup. So twisted pair cable is called a wired Ethernet network, an older telephone network. So twisted pair, which shaded twisted pair cabling is the most common form of twisted pair cabling, and uses color codes, insulator, copper wires. So you could see that in the picture on the right of cable that are twisted, and the connector that I've used is either the RJ45 or the RJ11. So the RJ45 is the big one, and the RJ11 is the small one, which is used for telephone. Okay. And so we have still on connectors. So we've talked about we'll be looking at the different types of connectors. So here we're looking at the coaxial cable and coaxial cables and connectors. So coaxial cable construction. Coaxial cable has these connectors, And there are different types. The RG6, a heavy gauge cable with resolution and shielding for high bandwidth and high frequency applications. So you could see the order in which they are arranged, telling us this has this shield. So we can actually relate to this. For instance, our DSTV uses this. And then we can also see the RJ59 is a thinner cable similar to the RJ6. But in this case, used for low bandwidth, lower frequency applications. So, like for instance, your CCTV analog video uses the RJ59. So the BNC is an older connector used for digital analog audio video device. So you can see that here. It's actually like a legacy kind of connector. So we have the SCSI and the ID cables and connectors. Like I said last time, the SCSI, which is actually the small computer system interface, is the standard for connecting peripheral and storage device in daisy chain format, as you can see here. And the external SCSI cable is used for connecting older external SCSI device like scanners and printers. That's the common one you're seeing on to your right. And the third, which is the ID cable, which is also like a legacy kind of connector. It's actually also referred to as a PATA. It's similar to internal SCSI cable, but commonly with 340-pin connectors. So that tells you the number of pins that the ID cable has. So one connector connects the ID portion, the ID port on the motherboard, and two for attaching the ID drives. So you can see that if you look at this critically, this is one. These two can be connected to two different ID drives, and they can all work independently. But that is actually the legacy kind of cable connector. And then the monitor characteristics. We need to look at the characteristics of our monitor. Computer monitors are usually described by screen size, resolution, monitor resolution, native resolution, native mode, connectivity. So these are actually features of some settings that you can do on your monitor. So you look at the different resolutions that can be adjusted. And all this is just to give you a better output. Okay, so we can actually walk through them and see the different resolution standards. But then the resolution is measured by the number of horizontal and vertical pixels. For example, the 920 by the 1080 means that it has 1920 horizontal pixels and 1080 vertical pixels. So these are actually resolutions. So you can actually change, kind of adjust the settings. So this you can do to show your students what monitor characteristics have in terms of their clarity, quality, brightness, and size. So this is still the monitor times, pixel, tiny dots are capable of displaying red, green, and blue. Okay, you're looking at the correct color there, red, green, and blue. Dot pinch, the distance between pixel and screen. So these are like the attributes of your monitor. All of these constant ratios, so you can see all this even when you're setting a projector, for instance, because auto display information. So you can see that some of these functions actually are there, which the standard can be followed. So you can actually use multiple monitors. So adding monitors can increase your visual desktop area, improve productivity. So the added monitors enable you to expand the size of the monitor or duplicate the desktop so you can view additional windows. So many computers have built-in support for multiple monitors such that you can actually connect one to many you still have access to content. So to connect multiple connectors to your computer, you need to enable your computer to support multiple computers, monitors, and gather the appropriate display cables so that you can actually connect it from one CPU to multiple monitors. So this is the computer configuration. And so the motherboard can be upgraded. So we're looking at upgrades, computer hardware. So motherboard upgrade. So computer need periodic upgrade, of course, for various reasons. User requirement change, upgrade software packages required for new hardware, which is the firmware. New hardware offers enhanced performance once that is done. If you upgrade or replace a motherboard, consider that you might have to replace all the components, including a CPU. So if you upgrade or replace your motherboard, consider that, and then also consider the heatsink and fan assembly and the RAM as well. They are critical when you're doing this replacement. So a new motherboard must fit into the old computer case, and power supply must support it. So you must actually look at the form factor of the computer case. Is it tower type? Is it horizontal type? You need to actually be sure before you fit in that motherboard. Like question was asked, the standard, when it comes to for CPU, you must because the computer case, you must look at it from the different types of computer case. That's from power type to desktop type and all of that. This is actually important so that you can actually know the form factor of the motherboard that actually can fit with that computer case when you're doing your upgrade. So steps to upgrade a motherboard. Step 1, record how the power supply case fans is lead case button attached to the old motherboard. So you need to actually record all this, the convention of where all these things actually connected to. You need to note that. And then disconnect the cables from the old motherboard, of course. You're doing upgrade. Disconnect and remove the expansion card from the case. So you need to disconnect and remove the expansion slot. Expansion slot, that's a card from the case. The reason why you need to disconnect and remove the expansion card is because when you're doing this upgrade, there's no need for you to have all these assembled. So you need to remove them one after the other. So record how the old motherboard is secured to the case. So you need to look at the pre-installed and configured system and be able to follow the procedure to see how they've been deployed. So remove the old motherboard from the case when you're replacing this one. And 6, identify where all the connectors are such power, SATA, fan, USB, audio, front panel connector, and any other on the new motherboard. So you need to identify where they are. Replace the old input-output shield with the new one. Insert and secure the motherboard into the case. And then 9, connect the power supply case fan, case lead, front panel, and any other required cables. All these you have to discontinue before you do the upgrade. So you don't do upgrade while there's power going through the system. So here we're looking at the CPU upgrade. So one way to increase the power of a computer is to increase the processing speed by upgrading the CPU. So the new CPU might require different heatsink and fan assemblies. So all this you have to look forward to. So here in this picture you can see what a typical CPU looks like. So when I ask some folks what is a CPU, they go point at a desktop system. So the new CPU might require a different heatsink. So if you're changing the CPU, you also need to check the fan. You also need to check to see if it has the heatsink to be able to absorb heat from the CPU. And then the assembly must physically fit the CPU and be compatible with your CPU. Okay, so you don't need to force this. You have to look at, you have to, like we said in the last class, you need to look at the orientation. So you orient the CPU such that it can fit into the socket. It must also be adequate to remove the heat of the faster CPU by installing additional case fans. All this is to take off heat from this working CPU. So each time they work, it produces very high amount of heat. I've tried this before, where the heat sink is removed, the CPU is powered on. If you just touch probably the back of the CPU, you could see how hot it is, hot to the point that it can actually hurt your hand. So that tells you the kind of heat they produce. So you must apply thermal compound between the new CPU and the heat sink and fan assembly. This is the precaution you must take if you want the CPU to actually stay for a long time. So storage device upgrade still. So there are several reasons for installing an additional drive. What are the reasons? One, increase storage space. So when you do storage device upgrade, you have more space. Increase hardware speed. Speed increase because the surface area where the information are housed is small. Install second operating system. Store system swap file. Provide fault tolerance because of the alternative routes to take, and then back up the original hard drive because they are now 2 or more. So when you back it up, like what you can see the picture to your right, you can see the professional there, the technician actually plugging another hard drive with the intention to back up the original information. So we have peripheral upgrades. So peripheral upgrades require upgrade like your keyboard. For example, you stop operating, you wish to improve the performance and productivity, and upgrade might be what necessary. So you can actually upgrade to high speed peripheral devices. So there are a few reasons for upgrading a keyboard, and the mouse. Change the keyboard and mouse to you might do these changes because you want to actually increase speed or performance, as the case may be. So peripheral devices also can be upgraded as well. So all this is just to enhance the performance and get some extra features. Then the power supply. So you can see the typical example showing us the power supply. So you can also upgrade. And when you're upgrading, ensure that those features are there. The fan is there to blow the heat. The vents are there to allow heat to go in and all of that. So this is part of upgrade. So we also look at the lab. So in the lab, you will gather information about the hardware components so you can upgrade your customers' hardware so they can play advanced video games. In upgrading, we talked about the RAM, we talked about all those components that ought to be upgraded. And the reason why we talked about the upgrade of this component is because when you upgrade them, you have better performance. So that's the essence of upgrade, and you have to know which of the components to upgrade and ensure that we get a compatible drive each time we want to do that. So we have a thick and a thin client. So computers are sometimes referred to as thick client or thin client. So sometimes called the fat client or the thick client. So standard computers with their own operating system, a multitude of applications and all that stuff. So the technology here is that you have one that has all its operating system, all the resources, and one system unit, and then it's being assessed by other client system. So that's you're looking at thin client system. So these are actually to tell us that when you have this kind of computer setup, you can actually control it from one point. Okay. So standard computers with their own operating system, a multi-node of applications and nothing. They are standalone systems and do not require a network connection to operate, as all the processing is performed locally in one computer. So you can see here that that's in one computer, but in the case of a thin client, low-end network computers that rely on remote servers, so you can see this rely on remote servers, but these actually do not require a network connection in the sense that all of the processing is performed locally by one system. But the second one requires a server. So that means you have a server as one of the systems, and that system actually points to the other system. So sync line requires a network connection to the server. So that means you must connect them. You must configure that network so that they can be able to share resources. And the main information will be coming from the server. So they are all dependent on the server. So the server must be up at every point in time for all the systems to connect. So we have a network attached storage device. These are servers. They connect to the network to provide file level data storage to client, which can be accessed anywhere in the day remotely. This specialized computer is sometimes single purpose, running a stripped down operating system to perform only the function of the file serving. So what are we saying here? We're looking at another kind of storage, network attached storage on the network, and these also systems can access remotely from any angle they are. Sometimes the device can offer additional functionalities such as media streaming, network services, automated backup functions, website hosting, and more, because it's a server, so you can actually host the website. But what we're saying that this is a network attached storage system that helps you to create connectivity, helps you to share resources, and helps you to actually automate back functions. So we're saying that these are a specialized kind of computer servers which can be deployed in our lab. So protecting the environment, if after this deploying all of this, there's a need that the waste should be deployed and should be appropriately kind of disposed such that you don't mess up with the environment. Okay. So the safe disposal method, so the proper disposal or recycling of hazardous computer components is a global issue. So it's not only just in Africa, West Africa. It's a global issue because after usage of all these things, how do you dispose them? If you dispose them wrongly, they can actually affect the environment, even affect kids and all of that. They are harmful. And so how are they disposed? So make sure to follow the regulation that govern how to dispose of specific items. You need to note that. And an organization that violates these regulations can be fined or face expensive legal battles because of the health hazard that these items can actually pose. So regulations for the disposal of these items vary from state to state and from country to country. So you're looking at batteries, looking at toner kits, cartridges, developers, chemical solvents. So these are the different types of disposal items. And then we're saying that if they must be disposed, they must be disposed appropriately so that they don't cause harm to the environment because of how they kind of we're talking about if they're not properly disposed, they can actually cause environmental hazard. So there's a need for proper disposal. All these are not supposed to be thrown out anyway, so they have to be properly collected. But then different countries have their regulations, and so you have to stick to the regulation in your own country. And then if you open up the device, the instructions how to dispose it are also written. So what we're saying is that in the lab, you need to tell the students the implication of all this so that they also help in the future to control our environment. And so while you're doing that, this also you can do using the safety data sheet. So a safety data sheet, commonly known as a materials safety and data sheet, is a fact sheet that summarizes information about material identification, including hazardous ingredients that can affect personal health, fire hazard, and first aid requirements. But all these actually are in the manual, which have to be studied and such that we can follow the procedure what to do. So the SDS contain chemical reactivity and incompatibility information. So this is still an issue. It also includes protective measures for the safe handling and storage of materials and spill, leak, and disposal procedures. So we need to study the safety leadership to be able to know how best to handle some of these expired or, what I said, used computer component. Like we stated those items in the last slide, so you need to watch out for them, follow the procedure, look at the safety data sheet from the manufacturer, and get to follow the procedures. So all that help on how to dispose of potential hazard in the possible safest manner to help us curtail the spread of this hazard in our environment. So we need to follow this procedure. So in summary, what we're saying here is that we've looked at the BIOS, the EFI setting, explain the electrical power system. I'm looking at it from the point of your current and voltage, the amount of electrons that are actually transmitted from one point to the other. With the ampage, we also talk about the voltage. Also, we talked about resistance also. So all that we said that Ohm's law is current times resistance, which is voltage. Explain the Ohm's law concept, and we looked at how they explain computer functionality. We describe monitor characteristics. We look at the different features of your monitor, and then be able to explore that, and then explain safe disposal methods to protect the environment, that's our environment in which we live. Okay, so these are basically what we discussed under chapter 3. So we have looked at chapter 3 from that advanced perspective. All the process of both of the settings that you have to do and why you're doing them, and the security aspect of the hardware also was looked into. And like I just talked about the electrical part of it, and then the computer functionality, because we need to know how the computer functions so that if there's certain faults in one area or the other, you know. Like for instance, if the CMOS battery fails, you know, when you see your date actually not working well, you begin to suspect the CMOS battery. So understanding the functionality of the computer helps us to also troubleshoot the computer as well. As we'll be seeing in subsequent chapters, we'll be talking about troubleshooting the network and all of that. So before you troubleshoot something, you must know how that system works. You know, it helps you. And the good thing about it here is that we've seen it from the angle of assembling the system, we've seen the angle of actually explaining the functionality. So all this will help us to also rectify the issues once there's some problem with the system. And so we also look at the safe disposal methods to protect the environment. So these are actually all that we have discussed in this chapter, and many more. So I would advise that we take our time, we go through the chapter again, and if there are questions, things we don't understand, and then we can always draw my attention. Like I said before, in the next class, maybe in the first 5 minutes, if you have questions, you can always ask to address the previous chapters. Maybe the course of reading, because one, you're meant to ask me questions at the end of each chapter, and then you're also meant to go read, possibly if you have not been reading, and then when you come back what you've read, if you have some issues trying to understand certain concepts, you ask questions. Now we're doing all of this because, like we said, you're an instructor, you're going to have so many students under you, so there's a need for you to be able to explain all these concepts properly. Okay, are we asking questions already? So this is question time. Marilyn, are you there? You told us you might not be there. Oh, lovely. Thank you so much. And so this is time for questions. So we want to kind of hear from you what you don't understand.
Guys, do you have any question?
Yeah, hello.
Yes.
Hi, Joseph.
Hello.
Yeah. Yeah, Joe,
Yeah.
I hear you.
My question. Yeah, as such, when your computer is running slowly and you wanted it to run faster, as such the overlocking, which other ways can you also do to make the computer run faster?
Well, apart from the overclocking, which we mentioned,
Apart from the overclocking, it's not.
Apart from the overclocking, you can actually increase the RAM. The RAM also help to increase the speed of the computer. And if you're not looking at getting any physical hardware to probably upgrade any physical hardware to increase the speed, then you can also look at the task manager trying to stop some of the applications that are running which probably are not needed. You stop them, and so you just have few that are running that are actually needed. Because sometimes some of us will have several applications running on our system without, we're not doing. And so they actually can take up so many memory and slow down the system. So you can reduce the number of applications running on the system. You can increase the RAM memory to increase the speed. You can also make sure you have less application running, like I said, and then be sure also at every point in time that you don't have virus in your system, because that actually can slow down the system. So, in addition to many, so these are some of the things that I say for now.
Okay, thank you.
Yeah, you're welcome. Thank you, Jim. Any other questions? Hello, are we there?
Yes. Do you have any other questions, Simon, Salia, Suleiman, Jacobo?
Okay, Simon is there. Okay.
Hello. So if they don't have questions, I have one related to the NetACAD tool. I was doing the chapter 1 keys, but when I go to grade completion, I don't see mine completed. I see, for instance, that Joseph has 100% in chapter 1 keys, also Jacobo, but in mine, it doesn't show that I did the keys. So I'm worried that some of the other teachers also have completed keys and it doesn't appear as completed.
Okay, I think I need to check this to be sure. Apart from yourself, any other person with that issue? I need to check. You are the facilitator for this program. I want to see if you have.
Yeah. So in grade and completion, if you go to the Zoom close to my name, you see that I have 100%. But inside of the report, it doesn't appear. So maybe some of the.
Okay, doesn't appear on the grade book?
Yeah.
Oh, really?
Do you want me to share?
You're talking about the grade book. It doesn't appear on your grade book.
Yeah. Do you want me to share my screen?
Yes, sure. You can share your screen.
Okay. Let me check. Where it is here. I cannot share it.
You cannot? Who is the host?
No.
Oh, I'm the host.
Okay, now let me share my screen. So if I go here, I see Joseph 100%, Jacobo. Mine, I don't see it, but if I enter here, I completed on Friday.
Okay,
You see?
great.
But if I go back, I don't see it here. So I'm worried.
Is that a chapter exam or the quiz? Can you go back again? Let me check.
The quiz, my exam is not.
Okay, you did chapter 1. Okay, did you do chapter 1 quiz or chapter 1 exam? I'm saying chapter 1 quiz. We have the quiz and we have the exam.
Yeah, my exam is not activated.
Really?
Yeah, but the quiz here in the quiz list.
Okay.
I'm worried that some of them have done the quiz and it doesn't appear as mine.
I
will go one by one and check, okay?
Okay.
And I will tell you if there is other cases, similar cases.
Okay, fine.
So we can check.
You can rectify that. You can help me with that. Maybe send me an email.
Perfect.
So I can work on that.
And my exam is not activated, it's disabled.
Disabled? Can you click on it? Let me see. Okay.
So if I go here to exam, it's not activated.
Why not click as student? You know, you logged in as a facilitator. You need to log in as a student.
Yeah, as student. Here I'm entering. I also see the exam here as disabled.
As a student. Oh, really? Okay, no problem.
Yeah,
I'm going to
you can see because you can see because this is straight and this is dot.
Okay. I'm going to check it out. So can you just help me check if there are other persons?
Perfect. I will check also if any other attendee has the same issue, so I can send you an email with exactly the ones that are in the same situation.
Okay, that would be lovely. But I could see that the chapter exams, some of them haven't attempted any of the chapter exams. The page is fine. I mean, we have chapter 1, 2, 3 exams up to 14. In as much as we have the courses.
Yeah.
So many of them haven't attempted
it.
Hello. Yeah, I think they will show good. They will show good almost.
You said? Hello.
Hello.
You said what? Yakubu?
Yes, please. I've done my chapter 1 and 2 quiz and then the chapter 1 exam. On what we showed, I saw that my chapter 1 and 2 quiz are above 100%, but I didn't see the chapter 1 exam. I'm yet to do the chapter 2 exam.
Okay, you're not seeing the chapter 1.
Who's speaking, Yakubu?
Yes, please.
Okay, quiz, an exam.
Can you check?
Yeah, I can. Can you see my screen?
Yeah, I can see your screen.
Okay.
No, I'm not seeing the screen yet.
If you can see my screen, this is Jacobo, chapter 1 quiz and 2 with 100%. And then chapter 1 exam, it appears as done.
Yakubu, are you okay with that?
Yes, please. Yes, please. Since it appears as done, I'm okay.
Yeah, I will check. I will check everyone's results. So and I will double check with you all. So I can send the report to the instructor, to Dr. Daniel, and say this one doesn't appear, this one appears. Okay.
Okay. I think so far we have Jacobo who have written chapter 1 and 2 exam. And then Joseph also.
Yeah, Joseph, and I think Isa, which has dropped because of network issues. I think that at least three of them have completed the exam, but I will double check with everyone.
So with Isa, there's nothing we can do about it for now. Okay. Hello?
No, Isa had network issues and his connection was lost like 20 minutes ago or 15 minutes ago.
Oh, wow.
But I think he did one of the exams.
Okay.
So
you do.
I will double check later and we'll let you know.
Thank you very much. So you do me a mail to let me know those who have issues. Okay.
Perfect.
Okay. Thank you so much. Thank you, Adams, Margot, Simon, Falia.
Thank you.
Here we are. So do have a nice weekend.
The same to you.
Yeah, okay. Yeah. So bye for today.
See you other time.